So we've looked at the scalar product, what it is, the two different variations we've got of it and how we calculate it. In this video, I'm going to set you a few questions based on this. I want you to read the questions, pause the video, have a crack at them, and then come back and check your answers with what I do here. So here you go. First question, I've given you 3 points, E, F and G. I want you to find what EF dot EG is, so the dot product between the vectors E to F and E to G. Second one, I want you to find the size of the angle POR based on the information that is given to you in the diagram. So I've given you the vectors P and R, find the angle between them. And then the last one, if I tell you 3 points, A, B and C at the coordinates there, I want you to show the angle BAC is equal to 48.2 degrees. So pause the video and have a crack at these questions. First question. So the first one was, if 3 points have these coordinates, EF and G, I want to find the dot product of the vectors EF and EG. Well, the first thing we have to do for this is figure out what these two vectors are. So I want to know what the vector EF and I want to know what the vector E to G is. So remember, to find the vector E to F, what that means is I have to do F minus E. So the position vector of F minus the position vector of E. Now remember, we can get these by simply looking at the coordinates. These position vectors come from the position vector from O, the origin, to this point. So remember, we can just write down the vectors by making a column vector out of the coordinates. So I know the E is going to be given by the vector 2, 1, negative 1. F is going to be given by the vector 3, negative 1 and 4. And G is going to be given by the vector 0, negative 3 and 5. So I've got my 3 vectors there that I'm going to use to calculate these two. First one, what I need is F minus E. So I take the vector for F, 3, negative 1, 4, and I subtract the vector E from it. To subtract the vector 2, 1, negative 1. Now it's just a case of performing the calculations. So 3 minus 2 gives me 1, negative 1 take away 1 gives me negative 2, and then 4 minus minus 1, well minus minus becomes a plus, 4 plus 1 is 5. So there's my first vector, the E to F. What I now want is the vector E to G. For that one, similar sort of formula here, the only difference is it's the vector G minus the vector E in this case. So there's our vector G. This is the one that we want to use rather than the vector F in this calculation. So I know then it's going to be 0, negative 3, 5 as my G vector, take away the E vector which is given by this, 2, 1, negative 1. So then just do each individual part on its own, similarly to this, and we get our vector. So 0 minus 2 gives me negative 2, negative 3 take away 1 gives me negative 4, and 5 minus minus 1, well again, minus minus becomes a plus, 5 plus 1 gives me 6. So there you go, there's your vector E to G. Now that we've got it, we can jump straight into our scalar product. We've got both parts here, we can have a crack at it. Now remember, if we've got two generic vectors A and B, and we do the scalar product A dot B, that's given by A1 B1 plus A2 B2 plus A3 B3. Each of these refer to the elements of the vector on its own. So A1 and B1 is the first vector element, A2 B2 the second one, and A3 B3 the third one. So we calculate each of these products and add them up. So in this case, our E to F dot E to G is given by 1 times negative 2 plus negative 2 times negative 4 plus 5 times the 6. Now it's just a case of doing these fairly straightforward calculations one at a time. 1 times negative 2 is negative 2. Negative 2 times negative 4 is 8, so it's plus 8. 5 6s are 30 plus 30. So negative 2 plus 8 is 6, plus 30 is 36. So there you go, EF to EG given by the value 36. Second question was find the size of the angle POR. So it's this angle here. Now remember, to find the size of the angle, think of the scalar properties and the scalar product that we had before. We know that A dot B was given by the first formula we used, the A1, B1, A2, B2, A3, B3, but it can also be given by the other one, which is given as the magnitude of A, magnitude of B, cos theta, where the theta was the angle between the two vectors. Now we talked about how we can rearrange this to figure out the angle. We can rearrange it and say cos theta equals A dot B over the magnitude of A, magnitude of B. So we have to calculate each part here, substitute them in, and then we can have a crack at it. A dot B in this case is given by the equivalent of P dot R. So P dot R, same idea as before, P1 R1, P2 R2, P3 R3. So the P1 R1 is 2 times 4, plus P2 R2, 3 times 3, plus the third element's 4 times 2. 2 4s are 8, 3 3s are 9, 4 2s are 8 as well. So I've got 8 plus 9 plus 8, 16 plus 9 gives me 25. So there's the top part of it, the P dot R. I then have to calculate the magnitude of each vector on its own. So the magnitude of P and the magnitude of R. So magnitude of P is given by the square root of 2 squared plus d squared plus 4 squared. Well, 2 squared is 4, so it's the square root of 4, plus d squared, which is 9, plus 4 squared, which is 16. 4 plus 9 plus 16, that gives me the square root of 29. For the R, the magnitude of R, same idea, same formula. But this time we use the elements of R rather than P. So it's 4 squared plus d squared plus 2 squared. Well, that's actually the same as this if you look. Same numbers, same idea. So R, magnitude of R, is also given by the square root of 29. Now it's substituting into the formula and working it out. So for these vectors here, we know that cos theta is equal to P dot R over magnitude of P, magnitude of R. Substitute in our values, we get cos theta equals the P dot R, which is 25, over the magnitude of P, root 29, times the magnitude of R, root 29. Root 29 times root 29, well, we can simplify that and make it 25 over 29. We can then calculate the angle theta by doing the inverse cosine of it. So cos minus 1 of the 25 over 29. Now this isn't something that gives us one of the exact values that we should know in this case. So all we can do is just stick it in a calculator and work it out. Stick it in the calculator, you get that being equal to 30.4503, and then it continues on after that. Question like this, round it to one decimal place, you get 30.5 degrees. So there you go, the angle between them, 30.5 degrees. It's these steps every single time. Use the formula, calculate each element in the formula, plug it in and get your answer at the end. Last one, if you get the 3 points, A at 2, -1, 3, B at 3, 1, 1, and C at 6, 2, 3, I want to show the angle BAC is given by 48.2 degrees. Well, one like this, it tends to be worth drawing a sketch so you can see what's going on. So you could imagine I've got my 3 points here. So there's A, there's B, and there's C. Set up a little triangle. And I want to show the angle BAC is given by this. So it's this angle here. That's the theta I'm looking to calculate. Again, think back to the formula we just used. Our cos theta equals A dot B over the magnitude of A, magnitude of B. We have to figure out the two vectors that are surrounding the angle, i.e. create the angle. In this case, it's this one here and this one here. So for this formula, I can equivalently think of it as being the vector A equals the vector A to B, and the vector B equals the vector A to C. So I can look at it in terms of these two angles. First thing we have to do though is get these vectors. So we know the vector A to B is given by the vector at B and take away the vector of A, and again we can use these coordinates and relate them to the origin, i.e. 0a and 0 to b, and just list them as column vectors to get what we need. So a to b is given by the b vector, 3, 1, 1. Take away the a vector, 2, negative 1, 3. So my vector for a to b, 3 minus 2 is 1, 1 minus minus 1, 1 plus 1 is 2, and then 1 minus 3 gives me negative 2. Same idea with a to c. This time though, instead of the b vector here, it's the vector relating to c, which is given by 6, 2, 3, and that's take away the same for a, 2, negative 1, 3. 6 minus 2 is 4, 2 minus minus 1 gives you 3, and then 3 minus 3 is 0. So now we calculate the three elements that we want. We want the dot product of the two, the magnitude of the first, the magnitude of the second, and then plug it all together. So a to b, scalar product with a to c, gives me 1 times 4 plus 2 times 3 plus negative 2 times 0. 1 times 4 is 4, 2 3s are 6, so it's 4 plus 6, which is 10. We then do the magnitude of each on its own and put it all together. So the magnitude of a to b is given by the square root of 1 squared plus 2 squared plus negative 2 squared. Gives you the square root. 1 squared is 1, 2 squared is 4, so it's 1 plus 4, and then negative 2 squared is also 4. 1 plus 4 gives you the square root of 9, which you should all know by now, is 3. Magnitude of a to c, similar idea but with its elements, 4 squared plus 3 squared plus 0 squared, all under a square root. Now 0 squared is nothing, 4 squared is 16, 3 squared is 9, so it's square root of 16 plus 9. Square root of 25, which we should all know as well, is 5. So now we plug it all into the formula and we see what we get. So we end up getting that cos theta is the dot product part, which is 10, over the product of these two magnitudes here. So it's 10 over 3 times 5, which is 10 over 15. That can be simplified to 2/3. So cos theta is 2/3, so to get the angle theta, we do cos minus 1 of 2/3. Cos minus 1 of 2/3, stick it in your calculator, and what you get is theta equals 48.189, and then it continues on degrees. Round this to one decimal place, and you get theta equals 48.2 degrees. Exactly what it asks you to prove in the question. We have to remember these steps when we're working with angles, and we're working with vectors, and we're working with a scalar product. Remember both variations of it and how you can work both variations to find any of these properties you are after.